Fucking Monday! Okay. Oh. And what a Monday it is. What are we doing? We're still working on restructuring and such and such. Hold on, I'm getting my coffee ready. We need the coffee. The butter is melting slowly. Very, very slowly. Oh, there we go. All right. Let's see where we're at. My notes says something. Manage shader initialization. Right now, every world container will overwrite the level stencil and height map, but only the main world should really need those at all. Yes, so. So, I think we should have... It's actually a little tricky here. Because the height map is used for rendering optimizations, which isn't necessarily needed for combat sequence or prefab editor, but there's no reason not to do it either. The level stencil is... What was that? That's like room allocations and stuff, I think. What was that? I don't think it's in there. It's probably in here. Init level stencil. Tile type building ID. Yeah. So that handles the rendering method, kind of. Handles transparency and stuff like that as well, to some degree. Yeah, I think we should just handle it the same way I'm handling the tiles. Probably. Meaning we have, like... We need to write some kind of index. But that also sucks, right? Because having to write an index... That means you need, like, another buffer. And how do we handle that? I feel like... you need several buffers just to handle... buffer indexing. Because, like... Let's say we have all our tiles, right? These are tiles. Then these need to be stored in a buffer. And we'll put them in this buffer here. right? And then it gets stored like this, like that, like that, like that, like that, like that, like that. It all gets stored like this in order in a one-dimensional array. And this is all good, no issues here at all. But then the issue is we're now creating multiple worlds so that we just have more of these, right? Then you have another one. But this one is blue. Then what? Now you need to store that here. Maybe it's just this big, right? Now you have that here. But now what we need to do is we need an index. This is 0, and this is 1. And that means that it also needs a count. So this has maybe like 0, 436. This is 1, and this has like 25. So that means we need to have another buffer here. That's literally just one long there. But it also has this. That contains that, and it contains that, right? And see, the problem here is that this is easy. But every single buffer that I'm using will need the same solution. That's the issue. So that kind of means that, like, do I use multiple buffers? Or I think we'll just have to make a struct. Oh, yeah, that would make sense. That would make sense. We make a struct. That way we can have this value here. And this value here. And then we can have a bunch of other values in the same index. And same here. That makes sense. Because the issue otherwise would be like having to have 1,000 buffers. So we need a struct that just contains buffer counts. And then we can have the same solution for everything. Okay. So then the question is, what counts do we need? And the level stencil isn't necessarily as simple, because it's actually a texture. So do I drop the textures approach? And just use a buffer? I think I should use a buffer, not a texture. That's gonna suck. But it's the only way to store the data. In a way that makes sense. Like a variable data amount. Because otherwise, if I store the level stencil as a texture, then I need to have like you can't do that. Like, I would need to be able to store the level stencils in like some kind of array or buffer, but you can't do that without the textures being the same size. And that wouldn't make any sense. Which means they have to be stored. You see, and this here, we have a temp array here, which is a one-dimensional color array. So we already have it. We just need to actually change it from set pixels apply to just storing this data. So this needs to be a struct instead of a color 32. Yeah. It's just an unfortunate pain in the ass. But it's also not really that big of a deal, I think. Now here, what is the level stencil actually? Like, what am I doing here? And why is there a 0 there? That's what I'm confused about. No. Where'd it go? Because right here, this seems to be the only place we're doing anything with the level stencil right now. And here, the only thing we're doing is writing tile type and building ID. I'm just confused as to why I have a 0 there and we have that there. But level stencil.load. Light origin tile type. Because I think that's what I do with it. We're only loading .r. Here we're loading a tile state. And tile state uses .r. Load .rgb. This is, so here's the building type or building state. Or no, this is the room ID really. Tile state.r. B. So what we're saying is that all we really need is... See, here we have tile data, building IDs, room IDs, roof IDs. But I think all of that is like baked in. I mean, what am I? Building ID, tile type. Right. The compute tile data array. Is this unused? This one is using compute tile data. One is using compute tile data. This one is using. This is the main one. So here we create this, then we set a main world. New compute buffer. I also recall. We're on a roll. New level. Hello, team. I'm working on... Well, overall, we're working on an RPG called Legends of Terrestria. But right now, I am restructuring things. I have like a combat sequence where characters are placed in like a little arena, kind of, when they fight. And I'm trying to restructure the code so I can reuse my rendering code and like the way tiles and objects are stored in the world inside of like a little pocket space, like a small world on the side that work like that. so that it can have light and shadows that don't interact with the world otherwise, or interfere with the world rather. So right now I'm trying to restructure everything for that to make sense. I'm trying to like modularize my code so that instead of just having like rooms and buildings and like a tile matrix, I'm going to have a world controller that contains a tile matrix and rooms and buildings and stuff. But it's a lot to rework. It's a lot. Mm-hmm. Refactors can be a pain. I don't have much experience with game graphics though, so can't help much there. Yeah, no, that's fine. It's mostly not like complicated. It's just super tedious and a little overwhelming because there's so much code and it's just breaking in like 400 places. I literally had 1,000 errors the other day. Now we're apparently down to 16, but it's lying. It's just unable to compile, so it's just saying 16. But yeah, this is basically kind of what I need to do. These are tile matrices, and they're being stored in buffers, one-dimensional buffers. And the fact that I only had one before, so now I have two, which means that I should append the second one at the end of the buffer. And that means that I need a way to access the second part. Like, this part needs to be indexed in a way where we know where it begins. And that's what I'm trying to figure out really exactly how we're gonna do and what we need to store, because I need to make a struct for like basically each index is going to be a world. So like index 0 is world 0, index 1 is world 1. And then we have a little buffer here that contains a struct that contains the starting index for each buffer. So here in world 1, we would maybe say that the starting index, well, it would actually be, this would be 0. So that would be like world 0 is pretty much always going to start at 0. World 1 is going to start at 436. But then we have like 8 different buffers for different things. Like how buildings are handled and transparencies and stuff like that. So that's why I need to have a struct to contain those, so that I can append things to the end of all those buffers as well, so we don't end up with like 40, 50 buffers. Because that would be stupid. But I wrote most of this code like ages ago, so it's a little tricky to understand exactly what things are doing and why sometimes. Is there a shared resource where all the worlds are laid out next to each other? Okay, now here's my issue. I don't know, like... I try to understand here, but I'm missing some important bits. Well, I'm a completely self-taught programmer, so usually when people say things, I don't understand what they mean either. But yeah, basically, this is a buffer, which is a one-dimensional array on the GPU. Basically. It can also have shared memory between the CPU and the GPU, but that's bad. Right now it does have shared memory, which is bad, because it's slow as hell. But it works, right? And then I'll just I have to write an allocator later, but fuck that. It works without, so we'll do that later. An allocator basically you like send data to the GPU and it'll put everything in unused memory slots and stuff like that. I don't know if an allocator will actually work, but it should, more or less. I know allocators a bit. I'm a C programmer. Fair enough. Yeah. So that's... It's not really very complicated what I need to do here. It's just that there's so much stuff. And it's also just like where, in what order do I do things really, and where do I do it? Because before I just had everything kind of in one script more or less, and it was like, yeah, okay, whenever I use the level editor to update like some tiles over here, I just instantly update the tiles, immediately write it to the shader and all of that stuff. So that's why it's a little complicated, because I have to rip things out where I'm doing things like on demand, where it instead should be like I do this thing and then later on we just run like we write things to the shader from like a queue of things that have happened in this frame, if that makes sense. Oh. Is it your own engine then? Yeah, it's made in Unity, but I'm just using Unity as a framework, kinda. I'm meaning to move to monogame, but for now, Unity is fine. But yes, this is a... Hold on. Yeah, here. So here I've just been making a mock-up area to just work on tiles for a while, but basically it's a voxel renderer. So I've created tiles that exist in voxel space. So that means that the entire game world is made up out of blocks, like Minecraft. And you can like walk behind and into buildings and stuff like that. So the renderer is actually rendering... It's a ray marching renderer that ray marches from the top of the screen and like down to whatever it can find. And then we render that tile. And then I've also programmed in like transparency for buildings, and we also have raycast shadows and light and whatnot, which is a little wonky with sprites and stuff. So that still needs a bit of work, but unfortunately it doesn't run right now, so can't start it. But yeah. So that's... what I've written in my shader here. It's a raycast, or it's not raycasting, it's ray marching. It's different. But it is a ray-based renderer. And then whenever I find like a tile to render, I write that to a stencil, like a height stencil, I call it, so that we know that we can just start rendering there, or we can start the ray there next time. And that way it doesn't need to do like any of its ray marching. Then the ray marching only handles transparency and like light casting and stuff like that. Now the question is, where am I? What do I need to do? Tile data. Let's see what we need. I think we check here. Building data. Compute building data. Compute building transparency. Compute tile data. Compute light data. Yeah. All of these things need to be. Compute array color data. What the fuck is that? Color blend mode Z. I don't know what that is. We do need compute object data. And then all of these textures, I think, need to be converted. Detail text, depth stencil, height map. I think there's actually very little benefit in using textures for sampling and like transferring data. I think it's actually I don't know exactly. It works. It's easy. But I think it's worse in every way. Basically, I have a 3-dimensional texture, or I had a 3-dimensional texture that just contained the tile information in each color channel, and then you could just sample it in 3D easily with just a coordinate. But the texture solution is slow because you have to update the entire texture to change anything on the map. But if you don't need to do that, then it doesn't matter. Height map. Like the only thing that you have to do with a buffer instead of a texture is convert the X, Y, and Z to a 1-dimensional coordinate, or index rather. Height map. I do think the height map should also be converted. Object collection text. Yep. That should be... That one is a little trickier. How do I handle that? Basically, do I just need to set like a maximum object size? Because I have a 3D texture. And to that 3D texture, I render every object in order of execution, right? So whatever renders first is just written to the texture. But since it's 3D, we're writing it to like Z 0, right? So the Z becomes the index of the texture of the object. So the reason I do that is because before we render the objects, or before we can render the objects, we write them all to a texture, a 3D texture, and then we write their indices to... We write their indices and their position to a buffer, and then we have an area buffer that like contains the objects contained within that area. And then when we need to render a pixel, we need to be able to check against objects for shadow casting. And that way we can just shadow cast against the objects in that area. And then we have the indices of them, which means we can access them in the buffer that contain their position. And we can also access their sprites in this 3D texture so that we can read their sprites and do collision against it with the light ray. But the problem with this approach is that if there is one large object, then the entire texture needs to be that size, right? Like, it uses up a lot of wasted space if there is one large object. And I also don't know what like the texture, what's the texture limit? I think it's really high though. Unity 3D texture limit. 2048 times 2048 times 2048. Okay, so we can have 2048 objects. That's fine. We're never gonna have that many objects. But it can be a little rough. That's a lot of data. Yeah. I mean, how much data is that? Actually. Okay, it's 34 gigabytes. Holy shit. That's fucking huge. That is big. But we're not making... It's never gonna be that big. Because textures, like objects are like 100 times 100, and we might have like 100 objects. So that's like 4 megs. An important question is how many layers you have of depth. Well, The way the texture works is that we rewrite the texture every time, every frame, literally every frame. Could be optimized to only be when like objects change, but that's gonna be every frame. So it's every frame. And my objects textures are not, you know, it's pixel art, so they're not that big, right? Like this is your average character. But it's 100 and something, right? But the second you have like a big lightning effect or something, like there might be a lightning effect that's like striking somewhere, like whatever. Is this now this big? And that sets the minimum necessary size for the entire 3D texture. Because that's the only way I can do it, as far as I know. Right? So now the entire buffer now has an X of 400 times 400 instead of 90 times 100. And then the Z is the amount of objects in the scene. Which could be... That can be optimized to only be on screen. Which I think I already do that, potentially. So it's one layer per object. Yeah, there's no like LOD or anything like that. So it's literally 1 Z per object. And there might be, like in a combat scenario, there might be like 20, 30 objects. But then you might have things in the environment that count as objects, like maybe there are like barrels or crates or, you know, maybe tables and torches and stuff like that, which might add up to like several hundred. But even if it is several hundred, I don't think it matters that much. Because like, let's say it's 400 times 400 times 400 objects times 32. How much is that? Now we're talking 250 megabytes. And that's like an extreme uppercase. But writing 250 megabytes to the GPU every frame might be a bit of a slowdown, but it might be okay too. Not sure. But it does run pretty well anyway right now. Because I don't know, right, how else would you even do it? That's the issue. Because... Unity... Or should we say HLSL maximum buffer length? Each content buffer can hold up to 4096 vectors. Oh? I don't know why you're doing all of this. It's because we're making a 2D tile-based game, and I am implementing dynamic shadow and light casting. And also dynamic transparencies for buildings where you can walk inside buildings and behind buildings. Stuff like that. Like you can do it kind of easily with the tricks and stuff. But not necessarily. It's the shadows and the light that makes it not possible to just be some 2D textures. More or less. Because then you have to actually make like pre-baked shadows, kind of. Or to some degree. Like you can hack it together a bit, but kind of get the effects you want. But it's also nice to be able to have an actual voxel world, because then you can also have voxel destruction. Like, the game isn't necessarily gonna have a whole lot of stuff like that, where you can just like destroy walls and stuff, but it's something that is possible. And you can also have, well, you know, it's something that you can have. But, and I also needed to make our own level editor. It's like yeah. It's really nice to just have the shadow casting now. It's a little tricky. And yeah, you can just make facades be just like a top layer or whatever. That does work. But you'd be surprised how fast it doesn't work. Because it only works in very specific, like, scenarios. And then you have to work within those limitations. Anyway, let's see. We need to create struct. And that struct is going to be a compute index container. Compute world index container, maybe. And then that needs a bunch of integers. It's not an index, it's a... Well, let's just call it that, but it's actually a count. light data. I don't know if it needs that, but let's just write it in for now. Ray color data. That one, not so sure what that is. Object data. Well, no, it is an index. Is there an automatic thing for this? There we go. This here, right, so we need to make a boolean here in the late update. That needs to say something like public bool update I don't know if I need something for each one. Like update level stencil. Like, do I need this for everything? I think I do. And that's what's kind of been throwing a wrench in it for me in my brain, because it's like, it's a little too much. Like, like update height map. I actually think I have one of those already. Update tile matrix. Update detail texture. That one needs to be changed to something else, right? And then this is what we need to do. We need to like update tile matrix. If we go to, holy shit, I have so much garbage open. The tile is over. There's the tile. The tile doesn't really have anything here. But the room here. This is what we're doing here. Here we're saying right buffer section. In here we have a right buffer section that takes an area and then it writes the tiles to that buffer area. And this is what definitely needs a section here that's gonna say, let's call it not update levels 10, so let's call it right to tile data buffer. And then here we say if right to tile data buffer, and then we need a function, but did I make the queue already? Because we have this is compute tile data. I was gonna store this. We're writing this to compute tile data. But it needs, like, start position and length for each. And I was writing a struct for that. Tile data. Tile data to right. Yeah, we have start position, area, queue int tiles to right. And so we need a public queue tile data to right. Something like that. Tile data to right queue. If tile data to right tile data to right queue dot count greater than 0. Or is there a better thing to do here? Like, is empty or... I've used queues like twice. Depend, single, skip, sum, take. Try DQ. Well, it should be while, right? It should be a while. While the count is greater, then we say tile data to right, tile data to right, and then here we say tile data to right equals yes, there DQ, and then we should just have to run this, kinda. Set data temp array. We have to create an array. So here there needs to be a for loop that says something like tile data to write dot I think this is actually a little bit wrong. That's what makes it even more confusing, that some of my old things are wrong and like only like 95% right, and then it's actually like it needs to change a little bit. That makes it even harder to refactor this shit. Because what's happening is like, let's say this lightning bolt is tiles. The way it's written right now, we are basically writing this as a square. But we are writing it in this kind of order. To a one-dimensional array. But it doesn't need to be like that at all, because we know, or we can know, the size of each operation, I think. So we could just write like this, or this, then, you know, write everything in the size that it is to where it needs to go. I think we should be able to do that at least. It's not really that big of an optimization, though. It doesn't really matter that much, but I can do that. Because writing is a very rare operation. Like, it's only something that happens in the level editor, really. But it would make the line tool less shit. Because that's when it becomes a mess. Because the bigger a line you draw, the bigger a section it has to keep rewriting. Like this, but the resolution is so small that it doesn't, things like that aren't really that big of a deal for the most part. Even though it is a problem. Yeah, see, here the tricky part is... we have to update the tools. Because the tools should only need to queue an actual tile change. And if it has queued a tile change, it can queue the same indices to be updated. I don't know why I'm doing it like this. There was like something when I was writing, making these buffer writes, where for whatever reason, I felt like I had to do it this way, where you write like each strip, and then the next strip, and then the next strip. Because it was like better. Because I have two implementations. I have one that write the data in strips like that, and I have one that write each tile individually. And the difference there is just that the one that writes it individually, the reason for that was because we are actually not writing it to the tile matrix. Because here you can see that we're actually reading from the tile matrix what we are putting in. We just have like an area that indicates that that area of the tile matrix has been updated. So then we rewrite that area of the tile matrix. But for a preview, like when I have like the line tool selected and you draw a line, it doesn't write to the tile matrix until you release the button. But we still have to write it to the buffer in a way, which means that we have to hijack the buffer. And there I wrote it in a way where it only writes like each tile separately, which is which works. It's slower, but I just feel like it shouldn't be. I shouldn't have to do that. But I'll be right back. Bathroom. All right. Turn off the devilish ceiling lamp. Oh, my butt hurts, dude. Oh my god. I have to stand. I hate that I got this, like, tailbone pain. It's fucking the worst thing when you're working at the computer. Literally the worst thing possible. I would rather have like a broken back or some shit than my ass hurting when I'm trying to sit. I think having your back broken would probably hurt when you're sitting too, but you know. There we go. All right. So this here exclusive range is generally used for writing whole arrays where we get a length of 10 from 0 to 9. Inclusive range is used for writing a tile section, e.g. x equals 5 with an area of 5 equals 5 to 10. Am I retarded? I might be. See, we have an exclusive range thing here. Is this ever false? But here it's false. In the room. Why would the real room need to be false? It's because if I'm writing... If you're writing one tile, then that's like, let's say it's got an x of 1, and it also ends at an x of 1. That gives it a length of 0. I feel like this is so overcomplicated. There's no way it needs that. This whole right buffer section has been haunting me for like the last 3 streams. It's so annoying. I want to just get rid of the inclusive range entirely. There's no way we can't make that work without that. See, I think we should rework this entirely. Perhaps. Because right now, the way this kind of... Well, I mean, it doesn't need to be reworked, but... Because the way I'm handling this right now is that we have a starting position inside of a... If we go back to this one, we have a starting tile position. So I just tell it like, yeah, we're writing from here. And then I give it an area. That way it's like, yep, we're writing this. And then it goes in here. And then it just writes that entire area. One strip at a time. But it shouldn't work like that, really. It should just always be... You feed it strips. That way you can have strips that look like this. And it's just going to be like, yep, we're updating this and that and that and that. But you can still do that with this implementation. Right? All you have to do is just write a for loop around this and only give it areas that have an X and a Y that is 1. But I feel like that's a little bit of a bad implementation, but it does work, right? And basically the area if area equals 0, the area should always be like a minimum of 1. Like there's no reason to do anything else. It's better to just have this function in one way and then convert whatever edge case scenario somewhere else into the way that this function wants to work. Not have this function that takes like 3 different ways of writing to it and handles that. That's terrible. I hate this function. Even more so because I have 2 versions of it. Which is even worse. This one handles... Well, I kind of need to have that, I think. Because I need to have... One of them, like... This is a way to write to the buffer, right? And one version writes from the tile matrix. And we're basically telling it that, yeah, this part of the tile matrix has been updated. Please update it on the GPU. And then it does that. The other one writes data supplied to it, temporary data, to the GPU. But I think that's bad. Because that's not how it should work. It's one of those things. It's a little annoying because the temporary, like, preview tile isn't really needed for anything, I think, other than for level editor tools. But so that's why I'm a little bit unsure, because I can just temporarily overwrite the data in the tile buffer on the shader or in the GPU, but that's slow as shit and it sucks. Because then whenever you draw a preview, you have to overwrite data in the buffer, and then whenever the preview leaves that area, you have to re-update it with the original information. So that works, but it sucks. The other alternative, which I think is the better alternative really, but it also sucks, is to actually have like a preview buffer that has like an X and a Y or something like that. Or it has it has an X and a Y. More or less. But the issue with that is that the buffer would basically have to be the same size as the original tile buffer. So I would need to have like a full fucking copy of the original buffer, because like how else would I do it? Because I can't just access like an index using the tile that we're checking, because we need to check something on the screen, and that's going to access a tile. And then draw that. So how would I overwrite that with a preview in a lightweight manner? Like if we just have a buffer that is dynamic and the size of the preview, then how do I access the correct tile from the preview when we are just checking like against the tile? Like I would have to iterate through the entire preview buffer until we can match an X and a Y. More or less. Or create an index that we can match, but we still have to iterate through the entire preview for every pixel on the screen. Which is also stupid. That's why updating it every frame made sense because of that. Oh yeah, I did have an idea for it before. I didn't like that though, but it works. Basically, you have a swap buffer that lets you like swap out the data on the GPU until the preview doesn't exist anymore. or you swap out the data for that frame and then swap it back, but that's like, now we might as well just be checking, like iterating through the entire buffer. I don't know. Writing a fucking swap thing sounds super annoying. Because right now the tile data is in shared memory, which is ass. It's part of why the game actually runs kind of poorly. It still runs at several hundred FPS, but it should run at like 1,000. Easily. But it doesn't really matter that much, because it doesn't need to be a good solution, because it's only for the level editor, really. I almost think the swap solution is like the only thing, because writing to memory works, but that solution needs to be changed. So writing to memory doesn't work. So in reality, writing to a swap buffer, or writing a preview buffer that has an index that represents a real tile position, And then you have another buffer that's the same size as that buffer that you can then swap the original tile into as you then write the preview into the main tile, then you render, then you swap it back at the end. That it's a retarded solution, but I think it works. I need to write that down. Create. I mean, I don't want to use the term swap chain because I don't know what the fuck that means, but I don't know if that's what that is. Swap buffer to temporarily store original tile data while drawing preview. Contains 1D buffer index and tile data. Yeah, that way we can get rid of one of these. So what would that look like? Compute object data. We would need a struct that looks something like... Is this doable? Compute tile preview data. Uint index. Compute tile data. Replacement data. Can you do that? In HLSL, is it safe to use nested structs? I don't trust HLSL. Okay. So it should be fine. So for a temporary compute tile data. No. Current document. What? Tile data. It's because compute tile data. Compute tile data buffer. New compute tile data. Compute structs. Yeah, how about we don't do that and we just go and put those in structs. And then we just create a region. Compute. The rest of the structs need to be sorted anyway. That's never gonna happen, but it needs to be done. Then we have a compute tile data here. And so we then need to have a public struct compute preview compute tile preview data. Compute tile preview data. Public int. I mean, it all uses uints, so is that what we should be doing? Just uints. Yeah. Index, and then here we have a public compute tile data. Tile data. Size of is uint times 5. Then we need a bunch of structured buffers, or rather we need 2. We need one that's called compute tile preview data. And one that's called compute tile preview data swapper. Swap. And these need to be compute compute tile preview data. So the swapper should just be compute tile data. And then the main controller New compute buffer. It's being set here. Then we need 2 new ones. And it's gonna be called a compute tile data preview buffer. And this is a tile data preview swap buffer, I suppose. And that's then a count. The count should be 0, 0. This is compute tile data dot size of, and this is compute tile preview data dot size of, and this buffer is the swap buffer is immutable. The preview buffer, though, is dynamic, I think. Well, I'm not sure. I think it's sub-updates. So I'm not sure. Static buffer, only initial upload allowed by the CPU. Because I have been using sub-updates before. Sub-updates is good for... and the default counter. Constant. GPU memory raw. I don't know what any of these things mean, I'll be honest. Structured. But I don't know if the sub-updates is necessary, really, either. Like, I think an immutable buffer is fine here, too, because the reality is I have to rebuild this buffer every frame. That's the annoying part. Same thing with the preview swamp buffer. It's also gonna have to be rebuilt with the same count as the preview buffer, and then we rebuild them and we discard them every frame. At least every frame that they are needed. Otherwise, we don't use them. And I have bools here, but I don't know if they actually work. Int. Draw. Tile preview. Also, I don't know if there's any point in initializing up here. And we need a public bool draw tile preview if it false. Set it to 0. Compute tile swap buffer. Let's set data new. Compute tile preview data. And this one was supposed to be just tile data. No, it needs to be preview data. No, hold on. It's the other way around. The preview. The preview should be regular data, and the swap buffer should be, and this one should be preview data. Because then we have the swap buffer that contains an index, and that's it. Shit. I think it needs another value, perhaps. But the other value could be stored in the index. We could append it to it. Basically, well, maybe. Index 2 and here index from. But that doesn't work. This needs to be like an actual int. Because this needs to be able to be like unassigned, and 0 is actually an assigned value. I mean, maybe it doesn't matter. Even if it would write to 0 if it was unassigned, maybe that's not that big of a deal. As long as it just always writes correctly, like it doesn't matter if this is an incorrect value. Right, it only matters if it breaks. I want a cookie. I want a cookie! It's the 2-hour mark. It's time to lose focus and completely spiral. I wish I could just be like normal people and just drink like coffee every 2 hours. I don't know how people do it. It's crazy. Yeah. I always feel bad. Well, like whenever I get to the 2-hour mark, I'm like, all right, I'm losing focus, man. This feels so bad. But the reality is like that's just how it is. That's completely normal. Usually you take 15 minutes breaks or something at work. When I take a break, it's usually like 3 minutes. That's why I used to go for a walk, but that takes like 40 minutes. It's shit stream. But yeah, it's unfortunate things like these that take some time here. The light casting does have issues that I'm not entirely sure how we'll solve it. I really like that we have dynamic light casting and shadow casting. It's really cool and it looks really good. But it has scenarios where it breaks and it just doesn't work properly without additional work. Like when you're casting lights on objects, it works when the object is small, because then you can just cast a shadow based on its sprite from its feet. But this doesn't work unless the object is standing at like a certain angle so that both of the feet are kind of level, so you can hide the beginning of the shadow at its like Y starting position. Because otherwise, if they're standing like at an angle, then you can't like match the shadow with its feet, and it's just gonna have like a shadow starting like strangely in the middle of nowhere. And the same with larger objects that might need to occupy like more space in the depth of the world, so to speak. You can't just cast a shadow based on its sprite anymore. So it creates a problem, whereas I can have like nice looking detailed shadows off of 2D sprites for characters, but then what do I have, like blob shadows for larger creatures? It's a little wonky. And I'm not entirely sure how to solve it. And there are also similar issues, but those are more manageable with, for example, let's say you have a tree. Like, the tree might not necessarily just be voxels, because making the tree, like the tree crown and everything, out of voxels, it's a little tricky. So trees might be like a hybrid of voxels and like an object, or just be an object. And then you end up with the same issue, right? Where you can't just cast a shadow based on the object necessarily. Though you can kind of like hack it together there and fix it by making the tree crown itself be like a flat texture, just like you would in just a traditional 2D renderer. And then you just make the light collide with it like its axis isn't up, it's in the depth, right? That way you can make it act like it's flat, and then the light can just collide with it, and then you cast a shadow down. And that'll just work in like every single scenario, more or less. But it's still tricky when you have because right now the voxels need to be reworked a little bit, because right now they're just 2D tiles that exist in voxel space. But what that means is that you have a voxel, which is a 3D cube that contains a texture, but that texture only exists on the front of the cube, not on the top. And that means that if you have a lone cube, then I kind of have to like hack how the top is rendered at the moment. And it also means that if I try to draw a staircase, it literally doesn't work, because I've shown this multiple times before, but basically here we have like 2 tiles on top of each other, and then we'll cast like a ray that comes like this to render it, basically. And then we just collide with this and we're like, yep, render this texture. But then if we're making a staircase, the staircase has to be a staircase, so it's gonna look like this. Right? So now when we cast a ray, it's gonna go like this. Right through, because it doesn't have a top. Because the staircase actually needs to be like this, right? And in order for me to achieve this, we need to have a top as well. So, and that's a very minor thing to add. Like, it's not really, but it is. It's just that then the level editor needs to handle not like a not just a tile sheet, but we need to have a tile sheet, and then we need to create voxels out of that, so that you have like a brick voxel, which is like index 0. That's a brick voxel, and then that voxel has a front and a top, and then you can paint this properly. So it is a little overcomplicated and it is a little difficult, but. And another thing is that if you cast shadows from the left, or cast light from the left or the right, right now I'm only handling the tiles like there's cubes, which works just fine for the most part. But like for a staircase, for example, that wouldn't work. So the staircases need to have, like, the voxels will actually need to have some kind of like depth map in order to be able to cast shadows properly. And it feels like it's, when I think of it, I'm like, man, is it too much? But at the same time, it's like, compared to doing 3D, it's like one thing. Like, is it that big of a deal for me to make a map for one voxel type when we're making like bump maps and bullshit for like every single texture when we're working in 3D? I don't know if it's really that big of a deal. The real issue is if I start thinking about doing that kind of stuff for objects, because that's a solution for objects too, right? Where I could give objects like a shadow, some kind of like shadow map for its side profile. But that's where things become ass, because then we'd have to like animate the entire side profile. Like, it could kind of work, but like not really. Like, if you think of it, like if I just use, like, because we have two animations, one when he's standing forward and one when he's standing back, or we have three animations, and one when he's standing to the side. So what if I just use the one where he's standing to the side as like this, when he's standing vertically, but that will also be drawn at a bit of an angle, and it's also mirrored in both directions, so it doesn't really work. It doesn't match up with the legs. But at the end of the day, there's always just a fallback of having more like blob shadows for the characters, which I don't really want to do, but it does work. Unless I can think of a different solution. To some degree. Because I've been pondering on like maybe you can create some kind of like point-based data structure. And all you need to do is like say, like, here's the body, here's like the upper body, and here are the feet. And that way you can generate a shadow based on that, kind of, but I don't know. I think that's kind of rough. I think you could also fairly easily convert this to a 3D engine. Ish. You just need to change the trajectory of the rays and just give tiles like a side. And you would be able to rotate it, because it's really just creating a data structure, right, for the tiles. But that's besides the point. We're just taking a little chill pill. A little bit. I'm gonna open the window. All right. And we think, my brain reset. Have I been standing here doing nothing for long enough? No. Now I don't remember what I was doing. We need another buffer here as well. Compute world index buffer, kind of. World index container buffer. It's a little bit of an oxymoron there, but compute world index container size of doesn't have that. We haven't finalized this quite yet, but it does need to have a public static int size of that then returns right now it's int times 5. These are all actually uints. Like that, yes. Now the question is it really like... No, there's... It should just be... I don't know. This should be sub-updates. Because we always know how many indices this is. So this should be sub-updates. This will only contain 1, 2, or 3 values. No, it will contain 2 to 3 values. Because it'll be the main world, the combat, and then optionally the level editor as well. So we need a public int world index count. I guess. But that shouldn't be necessary either. Because we can just get the world container index. Or count, rather. Have the worlds been created here? Main world. Yeah, so we've already created that here. Hmm. So then we can say the world index container buffer actually has count and that count is world container list.count. Right, so then we're creating the buffer and here we then have new compute tile data compute world index container buffer. Dot set data. We actually have to create the data. So it's like for world container list.count. Then let's see. It's a compute world index container. World index container array. And this is a world container list dot count. And then in here we're gonna say world index container array I equals new compute world container, which then takes tile data yeah, this is the count. So it's world container list I dot tile matrix dot what is long length? No, it's just length as a long. That sucks. Let's just do map size dot x times y. Well, this is actually incorrect. Because this needs to be different for each. This needs to start at 1. And that makes sense. Kind of. No, it doesn't. If we do I minus 1, then it makes sense. While here, we need the first entry should be just a bunch of zeros, basically. Because it always starts at 0. And then for whatever worlds come after, it's gonna be world container list I minus 1 dot, and now it was what? Building data. We haven't made a building data. Building data. Building transparency. There's a list of it, but that's not it. Because building data is a little... It's basically lying. Light data. And here we have object list.count, actually. But yeah, the map size makes sense, because that's how many tiles there are. The building data is a little tricky, because the building data is different in C# than it is in the HLSL, because the building is a little complicated, because it contains all the rooms, all the roofs, in order to handle individual transparency between all the rooms, so that you can be like in 2 different rooms and there can be transparency between them properly, while at the same time the building is also transparent. But that information isn't needed on the GPU. So there we have baked building data into just room information. Like, is this room transparent? Yes or no? And that's pretty much it. And then the transparency is kind of the same, where it just contains a bunch of transparency data, but I'm not really sure what we're writing there. Light data, this one is a little trickier. Because we're gonna need like areas as well. Let's see, we have tile data, light data. We're also gonna need public uint light area data. We have object data, public uint obj area data. And here things are a little tricky, because I'm not really sure how I should handle it, because I have object data, right? And the object area data shouldn't really be that pertinent to anything for the renderer, unless it's a collider for light. And in that case, the object area data should only contain light colliders. Only light colliders. Because otherwise, there's no reason. Like, the only reason we have that entire area function is to alleviate shadow casting. Holy fuck, it's cold. Ooh, cold outside. It's 5 degrees. It's pretty warm. think this. So I feel like is there a good word for this? Total? Combined? Total? There. Let's do that instead. That's something I should make for more things, like the world size? No, map size. Should have a getter for public int map size total. I don't know if total is a good word though. It's we're fetching a 1D array. Combined. Maybe that's a good word. Perhaps. And then building data. And here we're creating building data array. This is what we need to be able to fetch, I think. This is compute building data. We need a building data array dot count. No, it's an array, it's not length. So I don't know why. Is it really that big of a deal to recreate arrays? No, it's not a big deal. It's one of those things, like, I hate that I did some programming at school, because they just teach you annoying things. It's like, it's still haunting me, like, oh, recreating, like, creating an array is bad, blah, 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 but it's like, okay, doesn't actually matter, unless it's a huge array. Because this could be a list, right? I don't know. Like, Unity buffer set data. It takes a list, so it doesn't matter whether it's a list or an array. So it doesn't really matter. It's just like, do I recreate the array every time the building data changes? But the reality is that the building data never changes. Like, it only changes when editing the levels. Actually, it could change. Kind of. If I have, like... If we add, like, a destructible thing. Like, maybe a destructible door or something. But even so, like, not really. Because it would be preset to be something that's destructible. And I would set it as like a gate or a door or something. Because you can't just have open space on a building if you want the transparency to work. It still needs to be like a building area. So that it can count you as stepping inside of the building. It doesn't matter. This is what's gonna be annoying. Because it needs all of these things, right? So now that's the building data array. That is actually the correct thing. Next is the building transparency. So here we have a compute building transparency array, and that's going to be the same thing, length. Light data, compute light data, compute static light data array. Now this is gonna need to be like several. Compute static light data array length. Compute static light area data array dot length. Then we need compute dynamic light source list. And then we need dynamic light area count list dot count, object list dot count, light area map size combined. I think that one is actually not needed. As long as we have the light area data array, that kind of tells us. And because we'll be using the same sizes. This shirt is getting a little small. Not because I'm fat in the arms, but just because I've had this one for 20 years. I think it should shrink. It was always a little small. And then here, the spooky part here is that we're gonna need like a world index container boolean. The question is like public bool update world index buffer equals false. And then in each of these, here it says update static light buffer. Then this needs to say main controller dot update world index buffer equals true. Basically. And what we could do here is we could like individualize which one needs to be updated, but it's such a small buffer that that's not worth doing. And then in late update, unfortunately I have like 40 different late updates now, so it takes a while to find it there. Here, world container late update. After all of this stuff is handled, here, then we need to run if update world index buffer. Then we need to do that same thing that we were doing up there. But it's not done either, so like copying this is kind of retarded. What's missing? Actually, I think it's probably missing from the actual... But you couldn't. There. See, what are we doing here? We're doing map size, building data array, building transparency array, static light data, static light data, static light area, dynamic light source, dynamic light area, static, dynamic. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is now 9. What's missing? Tile data, building transparency, light, object list, object area data. That's shadow area count array. Compute shadow area data array. Actually, it needs to have both of these things. Compute shadow area data array dot count dot length. Then we put objects at the bottom, perhaps. Something like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. What are we missing now then? Shadow area. Dynamic light area. Static light area. Wait, actually, what's... Map, building data, building transparency, static light data, static light area, dynamic light area, shadow data, shadow area, object data. Cannot convert from int to uint. Okay. Yeah, and then that's pretty much that. Hello, Bisai, how's it going? I'm working on a turn-based RPG. Old Legends of Terrestria. So this here now. This needs to be broken out. We need to make a function here. Public void update world index buffer. And it just does this. We can also set the shader here, perhaps. Or maybe not. I want to separate that. Then we run that. And then we can go back up. Here. We can remove this and just say update world index buffer. And then that's good, I think. C shader dot set buffer. Have I made this one yet? Compute world index container. No, this one isn't done. It needs to look like that. Struct compute world index container. And we need another structured buffer. World compute world index buffer. No, compute world index container. Compute world index container buffer. I guess. Horrible, horrible names. This is the world index container buffer is set there. Yeah. So you set that. And then that's it. And then here we have execute compute shader, finalize dynamic highlight grid. And then down here, I want like a public void update C shader buffers, something like that. And then in here I want like I want it to be here right before we execute the compute shader. Update C shader buffers. And see here we have write to tile data buffer that's being handled there, kind of. World container late update. And see here we're doing like update light buffer, area buffer, blah 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 blah. So after this is done, this is where I want to update things. But we basically need to have something here that's just gonna say see. Update public bool update static light buffers. Update static shadow buffers. Update transparency buffers. But then there's a bunch of other things too, like that's why this is so hard, because like, okay. What the fuck do I actually need to update? So we have those there. I'm actually gonna put them here instead. Let's see. If update static light buffer update static light buffer false. Why am I doing this in the dumb way? 1, 2, 3, 4, 5. Right, and then this should really just run the shader set, which is gonna be like C shader dot set buffer static light I think we have to compile them here. So it's gonna say for compute light data. Compute light data array. Light data array equals new compute light data. And this is going to be the size of actually I need another one here. World container list of count. Here we need a int total light count. 0. Total light count plus equals world container list I dot light source static light source list dot count. Then we have a light count. Then we can use that to create the light array. Then we can go through the world container lists again in a nested for loop that breaks. Let's try that again. It likes no. Oh, come on. Oh man, I thought I had fixed this. I don't even remember what this was. This was like an issue with some sort of auto-complete or some bullshit. Which Visual Studio are we using? Copilot is the most likely culprit. Yeah, I think it was. I think this was like a Copilot thing. Am I blind? Show inline completions. No, it doesn't exist. I just don't, because I've fixed this issue before. I just don't remember what it was. It's just like show completion item filters. Show that it? I guess so. I don't know. Maybe. I love when they add things and turn it on and they call it experimental and it's just on by default and then it breaks everything. That's super cool. I love that. My god, I completely forgot what I was doing because of that. Shit. So, yeah, world container list. We are now iterating through world container list. I dot static light source list. But yeah, this should actually be... Oh, this is how I was doing it. Update static light buffer world index. Okay. A brain. It's almost empty. Yeah, the idea was that we set the static light buffer to a world index. That one is actually incorrect, because that one is just going to set it to whatever is the last one that updated. But basically, the idea was to set it to the lowest value, so that, for example, let's say we have 3 world containers. If we update anything on the 3rd world container, that would mean that we only need to update the buffer at the end. However, I don't know if I want to bother. I mean, it depends, right? Like, if it's a sub-updates solution, which for objects, I think sub-updates might be good. Might not. It might, like, giga stall it anyway. You'd never know, just from accessing, but I think it would be fine. Actually, maybe it won't be. Actually, maybe not. Because it would access the sub-updates buffer every pixel, almost. So I think that would still be bad, even if the sub-updates buffer is small. I don't think that matters. Oh, so the light buffer probably still needs to be immutable. Because the thing is, like, I think that recreating the buffer every frame, even if it's immutable, meaning we just make an initial upload to the GPU, I think doing that and redoing that every frame is still faster than writing to a shared memory space and reading it, because it's like we do an initial upload and then the GPU can just read from it many times that frame, versus uploading to shared memory and then it has to access shared memory many times per frame. I think the first option might be faster. And on top of that, you can optimize that further so that you... I mean, it would have to be recreated. That's the thing, because, like, if a static light disappears, then you would have to update the entire buffer. Unless you just hide it and just say they say that it has like 0 strength or something, that would also work. Then it doesn't need to be fully rewritten. But it would still need to be rewritten. Or you would need to have like some kind of agent that uploads the data and then overwrites the data in the index, which is what you should be doing. Good stream. Good stream. I don't want to stand anymore. Almost time for today. But not quite. It's still a lot of time left. 1 second. I really want a new table. The one I have is manual. I want one that's automatic. Jesus. I regret so much that I... Sad. Hello, Joho. How's it going? Whew. I've been tired this week. I think I have a bit of a flu in me. Not much, but a little bit. I'm sick as well. Well, hope it's just a little bit too. I mean, it's almost better when it's more, then you can just actually have an excuse. I'd rather be sick enough I can't work. Yeah. So let's see. World container list. What will the index be here? The index is U plus world container list I dot light static light list light source list dot count. But it should actually be I minus 1. This should be U plus I is greater than 0, then that else 0. And then this is set to new compute light. No, it's not new. It's just world container list I dot static light source list U. No, that's not it. It's light data, compute static light data array U. And this is this. That's what that should be. And this is kind of how everything here should be. So once this is done, it should be the same logic for everything. Basically, the idea is that every world has its own data, right? And whenever the data is worked upon or acted upon, whenever it needs to be updated, it updates its own data, and then it will tell the main controller that you need to update this data that changed. And then when we get to the late update stage, we just using booleans that say like, yeah, this needs to be updated. We then go through the world containers and we fetch the data from there. So if it's like the light source that needs to be updated, we then go and we fetch the light data from every world, and then we append them after each other in a list. So you end up with, like, let's say you have 10 lights in world 0, and you have 10 entries starting from 0 to 9, and then the next entry will be at 10 for world 1. And then there might be like 3 there. Then that goes from 10 to 12. And then if there's a third world, which would be the level editor's prefab editor, then that would go from 13 to whatever, right? Thinking you say data with an accent, then realizing I say data in my American accent. Yeah. I can say it in my American accent if you want. I can say data in my American accent. You can go check out some data at McDonald's and get some burgers. I can go watch some NASCAR. I just ordered Mackey's. Hell yeah, brother. Butter? Yeah. Yeah, Americans don't pronounce things. It makes it hard to speak American, because Americans don't pronounce anything. We pronounce everything. It's also why Americans are so dog shit at Japanese. Because the Japanese is like Swedish, but American is the complete opposite of how both languages are pronounced. Horses are so dumb. Horse. Hajime Mashita. I get so annoyed by weebs doing the try-hard Japanese accent. Well, that's how you're supposed to speak Japanese. You're speaking Americanese. But yeah, it is annoying. But it's not because they're doing it right, it's because they're weebs. That's why it's annoying. Weebs are annoying. That's just how that's just how it is. I say, and Charles is like one of the biggest weebs. This is a keep now. I was watching video game stuff, but then they say Shigeru Miyamoto with a pretentious wrong accent. Yeah. Shigeru Miyamoto. You are a weeb, you're a huge weeb. Big weeb. Weeb Charles. But yes, this is... Then here we say C shader buffer, set buffer. This is... compute static light sources. I believe. When you do that, need a kernel index kernel index. No, it's set data. Shader dot set. Why is it not set data? It's the buffer that has set data. Right, it needs to static light source buffer dot set data. And this is where it's a little tricky, because here you can just set the entire array. But here, if you have a managed buffer, you can set it in. You can set a start and an end index. But yeah, I think here what we want to actually do is do the whole compute static light source buffer equals new compute buffer. I need a new project. Mine got too complicated to actually finish. So will the next one. But I think it's okay to not finish your first game, I will say. I think it's okay to say, hey, I want to try something new. And not worry about making a demo sequence for the arcade machine. I think that's okay. We have a light source limit here. Do I just overwrite it? I'm not trying to build an engine, man. You have already built an engine. You've built a runner engine. It's just that it's an engine that operates within an engine. Congrats, you built an engine. That's what an engine is. The only difference between what I'm doing and what you're doing is that I'm at a lower level. Meaning I'm working on the rendering itself on my own. All programming is state machines. More or less. But then if we have a light source limit, what would the light source limit be? I don't feel like we need a light source limit. Yeah, it's not actually correct entirely here. But how would I write a generic allocator, right? Because can you just write raw data? Because the thing is, the way I think this should work, really, is that we should set a value where we expect to use this many light sources. We expect to use this many objects. We expect to use this many tiles. Well, the tile one can be a little bit more specific. But in general, I think that's how it should work. And whenever we exceed that, it should be increased by a certain increment that we preset. So like, let's say we expect 40 lights. Then we should just have a light array that is an initial size of 40. That way we have like a more reliable demand, I guess. And that way we can just write to it. And we wouldn't need to like recreate the buffer over and over again to resize it. Like we just make it have an initial size. We just overwrite the data on it up to like a point, right? Where as long as that point is within the scope of the buffer, then we just overwrite. And then we have like a count value. We have an index that just says like, this is the current maximum of this buffer, then we never exceed that. So everything else that's on that buffer is just garbage. But we keep the data there because there's no point in changing it because you can't remove it. It's pre-allocated space. So it doesn't matter. And then if we exceed the value, then we just increase the size of the buffer. At least until like the level up changes or something. I think that is smartest. But the issue there is like when you're writing to a buffer, you can just say like I'm writing this data type, this stride. Stride is how much data is there in each entry in the buffer. Again, buffer and array is like interchangeable. It's the same thing. But the issue with that is that if I have like a light buffer and a shadow buffer and an object buffer and a tile buffer, then that means that in order for me to be able to like ship data into the GPU, and then have the GPU kind of like move the data into wherever it should go. I would need like 1,000, like I would need to have the same amount of buffers that I have data types. So it would need, like I would need to be able to write raw data. Let's see if we can figure out if that's something you can. In HLSL. In HLSL, I have sub-update buffers, which lets me easily update the contents of the buffers, but this is slow. There are immutable buffers, but my concern is that each immutable buffer will take a certain type of data, such as an int or floats or custom structs. So this means that if I want to write some sort of allocation system where I funnel data into the GPU through a buffer that then writes the data over to the immutable buffers on the GPU side. I would need allocators of every data type. Is it possible to simply create a raw data allocator that simply moves memory and not data types? This is exactly what byte address buffer and read-write byte address buffer are for. Byte address buffer is essentially a raw byte array on the GPU. You read/write it in 4-byte aligned chunks using buffer.load, buffer.store. So your allocator system would look like one read-write byte address buffer as the staging/transfer buffer receives all data from C# regardless of type. Your compute shader reads raw bytes from it and reinterprets them using as float, as int, as uint before writing to the destination buffers. The destination immutable buffers can be typed. You just cast at the point of writing. On the C# side, you just write everything as uint/byte into the staging compute buffer. Structs, floats, ints, all treated as raw memory, matching exactly how you do a mem copy in C++. The key insight is that as float, as int are bitwise reinterprets, not casts. Same as C++ reinterpret cast, so there's no precision loss or conversion happening, just telling the shader how to interpret the bits. This is a pretty standard pattern for GPU-driven architecture where you want a single upload path feeding multiple type buffers. Yeah, that does make sense. Is that what I use kernels for? Like, I've never really understood the shader kernels, but if I execute a different kernel on a compute shader, I can then say, like, since we're running kernel like 6, that means transfer read-write buffer data to data array, for example. That way I can like tell it to execute a certain function after I've uploaded data, because that's also an issue, right? Like, I mean, I could just make one kernel, because what you can do is you can make one kernel that's just like a
a data uploader. And then you have like an integer that you just set, that just says like, if this integer is 1, then we put the data into this buffer. If it's 2, we put it into that buffer. If it's 3, etc. That way you don't need to have a million kernels. All right. Ordered a refurbished computer laptop from Germany. Hopefully it isn't retarded. Tiny little mouse eating a strawberry. I need to write this down. Create read-write byte address allocator buffer to write data into other buffers. Other buffers should have preset static sizes not aligned with its content. Extend on overflow by set value per buffer. Should write a struct for that, like a public compute buffer. It should be a struct. Compute buffer. Memory values or something. Memory. Compute buffer memory settings. Is that good? public int init value, public int current extension count, public int extension amount. I almost call it extension stride, but that's not really true. But I think this is all it really needs. Extension value. Init length. Length extension value. Current extension count. Let's call it E extension count. Does it need anything else? I don't think so. Just needs an init length extension count, length extension value. I think that's it. But the annoying part is that now it needs one of those for every single buffer. I think that is the right play. Just right click. There. Is this really what we're just gonna do? Just say settings. And this is called a compute buffer memory settings. New compute buffer memory settings 0, 0, 0. I do think they should all be uints though. There. wish I had a button to just align these. I think there is, but I don't know what it is. Let's ask. Is there a key combo in VS 2022 to align a multi-line selection with each other to format and align a multi-line selection to the left of the selection so that to make it easier to list things neatly. Control KF. Okay, if we do this, what will this do? Control KF. Fuck you. Align assignments extension. I do this often enough that it's worth actually checking. Hello! Game time soon? No, we have to do art stuff. I have to. As long as nothing like... I've been meaning to do it every day, but something comes up every day. And then I don't have enough energy left to do it. Align assignments. Have to close. Yeah, it's going alright today. Mostly just figuring things out. But I am figuring out how to handle the buffers. The annoying part here is that the way all of my buffers are handled on the GPU side is not correct. So, like, I actually have to fix them, which is going to be like the majority of the time this refactor is going to take. But I think it's not that big of a deal. Now here's the thing. It says Control-Alt-Bracket. What would that key combo be on a Swedish keyboard? Tools. Options, environment, keyboard, align us. Fuck you. Did you finish that huge world refactor? No. I'm mostly working on the buffers, like, still. Oh? Align? Edit align assignments. Control Alt All. Alright. Sure. Thank you. So nice. Alright, there we go. Basically, what I'm doing here now is I'm changing how I'm managing my buffers to some degree, where I'm going to see if I can assign some of these buffers with a like an expected memory size. Obviously, that expected memory size is probably not going to match with what's happening, but and I think I have to write a bunch of functions for each. But we're going to write an expected memory size for... Maybe the buffer should be stored inside of these structs or something, just to make it cleaner. Nah, I don't think that's... Maybe I should make a class that contains the buffer and the struct, so I can access it from one thing. That way I can just pass in a class to one function, and it'll just check. But basically, we're gonna have an initial buffer size, and then we're gonna also have the struct contains an extension count and a length extension value. That way, we will have an initial length, an extension count. Maybe I should have like a current length. Maybe that's worth having, because otherwise I have to do math every time I try to read it. Or we just add a getter. Turn init length plus extension count times length extension value. That might be fine. And that way, whenever a buffer is about to overflow, we extend the maximum allowed size for the buffer. And whenever we write to the buffer, we just write from left to right, right? So if any data on the right side of where we end up like not like stopping the write, all of that data will just remain what it was. It's just we're gonna just have an integer that says this is the maximum count of the buffer currently, even though that count is lower than its current maximum length, right? It's just and then whenever it it exceeds that, we will recreate the buffer and extend it, rewrite to it, and yeah, that's just gonna be that. And then we need to make a function. I'm gonna write that down too. Create function for writing to buffer in order to check if the buffer will overflow and then handle overflow. That's what we need to do. And this is compute buffer, right? Do I make a class? I think I want to make a class. Compute, what should be called? Compute handler? Compute buffer handler. Compute buffer handler. And then that's all it's really going to contain is a public compute buffer memory settings, and a public compute buffer. Like that. And then that's pretty much it, but we can write the handle script in here, right? So, like, instead of set data on the buffer, we have a set data here. That will do write to buffer, extend if necessary. Something like that. I think that might be good. But yeah, I'm gonna go and do some other things and maybe eat or whatever. And we'll try to do some art. I'm gonna try doing it soon, so we do it during the day, not after the day. That way, we have time to maybe do something tonight as well. And not work 12 hours. But, yeah. Until then, thanks for hanging. I'll see you next time. Bye-bye.